Hey everyone, so we're going to be doing the warm-up for the notes of day 18, and so these follow from the material we looked at yesterday. So it says, does each table represent a linear or exponential function? Explain. So we have our two tables here, and just like yesterday, we really just have to analyze the pattern of my x's and my y's. So for this first one, I noticed that, let me zoom in a little more. For A, I notice that every time I hop into the next little square in the table, I'm actually going up by 2. So plus 2 here. And then down here, I check that for my y's. I go from 2 to 4, from 4 to 6, from 6 to 8, which is again a plus 2. Now these don't have to be the same, but we do notice that both of them are constant, right? They just happen to be the same here. But as long as they're constant, this tells me that if I have a constant rate of change, then this means that the function represented by this table has to be linear. So then we have B. Gives us again the table of values. Let's see how these x's and y's behave. So my x's go up by 1. And my y's, they don't really go up by a fixed number per se. But if we pay real close attention, if I want to go from 1 to 3, I have to multiply by 3. And if I want to go from 3 to 9, I once again have to multiply by 3. And then to get from 9 to 7, I have to multiply by 3 again. So we don't have a constant rate of change, but we do have a constant factor. Which is 3. And so whenever data in a table shows that we have a constant factor, this tells me that this function has to be exponential. That's a linear. A, exponential B. C and D deal with just finding one single value with each of these exponential functions. So for C, we're really just asking, what is my y value when x is 2? So let's see, y has to be equal to a -3 times a 4. But instead of writing 4 to the x power, we're now going to write 4 to the second power. So then 4 to the second power is 4 times 4, which is 16. So this is again just -3 multiplied by a 16. And if we put this in a calculator, which I just did, remember to have a calculator handy with these exponentials, we're going to get that the answer is -48. And if we want to express it in function notation, let's say this was f of x instead of y, then we would say that f of 2, which is that x value we're plugging in, has to be equal to a -48. And then part D is the same. We are given an x value. In this case it's -3, and we're going to have to do the same deal. So let's see what happens. Y is equal to 2 to the 0.25 to the -3rd power. If you have a calculator, you can just put it in straight up like that. But let's see if we can do this by hand a little further. So 0.25, we can actually rewrite that as a fraction, which is 1/4. And now we have this negative power here that I definitely need to get rid of. In fact, the reason I changed this decimal to this fraction is so that we can see how we can get rid of this negative exponent. So if we remember the rules from last time, we know that this should be 2 times. We're going to flip this fraction on its head by getting its reciprocal. So instead of having 1/4, we will now have 4/1, or just 4. And because we flipped that fraction, my exponent turns into a positive 3. And so now we know that 4 to the third power, according to my calculator, is 64. So we get 2 times 64. And 2 times 64 is just 128.